Hello everyone, welcome to the project demonstration video of EEE 304. So this group consists of two students. We are student ID 1606044 and one student ID 1606045. Okay, so the project proposal was that was to build a online quiz system that can there will be 4 participants, and all of those participants will be provided with a button. Here we can see the buttons, and there will also be a judge who will also be provided with another button, and here we can see the button that will be provided to the judge. So the method is, whenever the judge asks a question, the students or the participants will be allowed to press their buttons, whoever know the actual answer. So whenever someone presses the button, he will be allowed to answer, and if the answer is correct, the judge will press this button and the score of the corresponding participant will be updated. And if the answer is wrong, this button will not be pressed by the judge, and so the scoreboard and the score of the corresponding participants will not be updated. And if someone has pressed the button first and then another one has pressed the button, the system will allow only the person whoever has pressed the button in the very first place. Okay, so let's see the demonstration. Okay, so this is the initial condition. This screen or this 7-segment display shows which participant has pressed the button in the first place. So let's consider the judge has asked a question and participant 0 has pressed the button. So here we can see this is the participant 0, or the first participant. He has pressed this button, and this display is showing now 0, which is participant 0 has pressed the button. Now if we see that someone else is trying to press the button, here participant 1 is trying to press the button, participant 4 is trying to press the button, the screen will still show participant 0, and if the screen will not allow others to answer. Okay, so after the participant has pressed this button, he will be allowed to answer, and he will answer. If this answer is correct, then the judge will press the button here, and the score of the corresponding participant will be updated. If the answer is incorrect, then the judge will not press the button, and so the scoreboard will not be updated. So let's consider that in the next cycle, the judge has asked another question, and the participant has answered. The participant 1 has again answered it, tried to answer it, and press the button first. And if the answer is again correct, the judge will press the button, and the score will be updated. Now let's consider in the third cycle, or in the third question, participant 3 has pressed the button. So here we can see sorry, my mistake, participant 0, 1, 2. This is participant 2. So participant 2 has pressed the button, and the screen is showing 2, which is the index of the participant. So if the answer is correct, the judge will press the button, and the corresponding score will be updated. Let's see. Let's consider the participant 3 has participant 2 has answered the next 3 questions, and he has scored 3. So we can see that the clear winner is participant 3. So the next segment is used to find out the winner. This is quite a complicated circuit, we can see. So this part finds out whoever has the highest score. So if we see here that participant 2, the LED corresponding to participant 2 is glowing, which means the winner is participant 2. So this is the score. This is the final result of our project. And now let's go deeper. Here we can see the inputs of the participants are passing through a register. The register, the clock of the register is cascaded by some OR gates. So whenever someone presses the button first, this OR gate gets activated and it acts as a clock for the register. So whenever someone presses the button, immediately this data is passed to the output of the register, and in the next, so that if someone else tries to press it, there is no clock cycle, and so the data will not be passed there. So at the end of this register, we can see there are 4 bits of binary. It's a non-binary data. We have to convert it into binary, so that's why we are using an encoder which is converting this data into a binary version. So in this output of this 4532 encoder, we can see that the output is a binary information, and this binary data is being converted by 74LS47, which is a 7-segment display driver which takes input as a binary and displays decimal data. Not decimal, actually hexadecimal data. Okay, so after this part is done, then let's move on to the judge segment. So the judge is provided with a single button, and this button is going to the clock. Okay, is going to the clock of the counter. Okay, so if we look at here, the enable pin of all of these counters are connected to the register output of the participants, so that whenever someone has pressed the button, the corresponding register is enabled, register output is enabled, and the corresponding enable pin enables the corresponding counter. So here we can see the counter. Whenever someone presses the button, the corresponding counter of that participant will be activated, and so whenever the judge presses this button, the counter will increase the participant, the scoreboard who corresponding to the participant whose counter is enabled. Okay, so after this part, we move on to the next segment where we discuss the part for the maximum and minimum calculation. We can see there are 4 results. We have to find out which one is bigger. So we are using some simple if-else conditions. Okay, so the outputs of the counters are passed here. So let's check here. Here we are considering the score of student 0 and student 1. Okay, participant 0 and participant 1 we are considering. So this is a comparator IC. If participant 1 has higher score, then this line will be activated, 5th pin, and it will activate the next segment of this part, and it will only the next segment will only be activated because there are AND gates. So if this button is 0, then nothing will happen in the next segment, and if this line is on, then here we will come. And in the next segment, as we know that student 1 has higher score, then we will compare him with student 3, right? We will compare him with student 3. So here in the next segment, we are comparing student 0 with student 2. I mean 3 means in index 2. So student 0 is being compared with student 2, and then if this line is activated, which means student 2 has higher score, then the next segment will be activated, and similarly we will compare student 0 with student 3, and so on. So this is how finally we will find out whoever has the highest score, and the corresponding LED will glow. Now we move on to the quarters part. In this quarters part, we can see that we have created modules for individual blocks that we used in Proteus. We have created module for register, we have created module for encoder, we have created module for up counter, and now just as the same way we are doing in the Proteus part, we are making the same output in Quartus as well. So we could see the register in this first register which we used in Proteus like this. Let me show you here. We used the output of the corresponding participants and passed them to the register and encoder. We did the same here, the register and encoder. We first stage is register, the output of the register was passed to the encoder. In the next segment, what we did was increase the corresponding encoder which has the enabled pin on. So here we are checking all the scores, all the up counters. If the enable pin, which is Q3, let me show you, up counter has the third input as enable. If Q1, Q0, Q1, Q2, Q3, any of these are on, then the corresponding score will be updated. So this is the method, and finally we are finding out whoever has the highest score. So we can clearly see that by using this if-else condition, which we had to implement in Proteus in a very complicated way, we did the same in Quartus in a very easy way. So finally we have our winner, the index of our winner. So let's see the output. Yeah, okay. So we can see the data is 0 1 0 0, which means that let me show you what this data means. This data is input to the register. Okay, so here is the input to the register. So this data means which participant has pressed the button. So if we look at here, as 0 1 0 0 means participant 1 has pressed the button. Okay, this is 0 index, so 0 1 2, participant 2 has pressed the button. Okay, participant 2 has pressed the button. So now what does this Q means? Q means, let me show you here you can see this Q is the output of the register. This Q is the output of the register. So we can see after this clock, the output is passed to Q. The register input to the register is passed to the output of the register. Okay, so Q, and this Q is then being passed to the encoder. Okay, so let me show what Y means. Y is the output of the encoder. Y is the output of the encoder, and we could see the output of the encoder was in binary. So the output of the encoder was in binary. So let me show here. Okay, so the output of this participant, here we are using one indexed code. So 1 2 3, this is the third participant, so the corresponding binary data will be 0 1 1. So after the next clock cycle, the participant 1, the Y will have the output participant 1. Okay, next, this is the system clock and this is the counter clock. This counter clock means that whether the participant has answered correct answer or not. So if we can see these two clocks, it means the participant 3 has given 2 correct answers. Okay, this is actually the button that was provided to the judge. Okay, so as we can see, this means that participant 3, I mean 0 1 1, has answered 2 correct answers. So his score, score 3 will be 2, and as the others have not given any correct answer, so the clear winner will be participant, this third participant. So the winner is 0 1 1, which means the one who has pressed the button, the one who pressed the button in the first place. I mean this Y. So This is the final demonstration of our project. Thank you. Assalamu alaikum.